Alright, here's the second part of that same video. Sorry, I couldn't complete it in the first part. Okay, so I was saying that a few more questions you would face from manometer in this regard, according to this, using this unit, centimeter mercury. So what are the questions that you might face? Like, if you look at this example, the question might ask you two things. One is find the pressure due to the gas supply in centimeter mercury, and in that case you will have to solve this, the pressure due to the gas supply. The other thing the question might ask you is find the extra pressure, or find the excess pressure above the atmospheric pressure, or it might say find the pressure above the atmospheric pressure that is exerted by the gas supply. Above the atmospheric pressure means that it is applying the pressure which is equal to atmospheric pressure, and it is applying something extra which is above the atmospheric pressure. How much is that extra pressure? Now if you look at this equation, the gas supply is applying pressure which is equivalent to atmospheric pressure plus this much pressure. So this is the additional pressure which is the gas supply is exerting. So if the question asks you what is the extra pressure the gas supply is exerting, or above atmospheric pressure it is exerting, you write 50 centimeter of mercury alone. You can't write anything else. You don't have to write the atmospheric pressure or add the atmospheric pressure. You just have to say 50 centimeter of mercury. And if you have to write it down in Pascal, if the question would have asked you what is the pressure above atmospheric pressure in Pascal, you simply would have done this. Pressure due to the gas supply above atmospheric pressure is H-rho-g, where again you would have taken H as 50 centimeter, which means 0.5 into 13,600 into 10, and that would have given you the extra pressure, the pressure above atmospheric pressure. Okay, so I hope this is clear to everyone. So this the answer would have been how much? 68,000 Pascal, I guess, right? So this is how, these are the questions you might face, that what is the pressure above atmospheric pressure, and you can write it in terms of centimeter mercury and also in terms of Pascal. So let's go through a few questions regarding to manometer. Read this question, the first one. See, this is the same question which I was saying. What is the pressure above atmospheric pressure of the gas in the cylinder? So what is the pressure above atmospheric pressure here? So the gas cylinder is exerting a pressure at this point, which is atmospheric pressure plus H-rho-g. So above atmospheric pressure is only this much. So we will use the formula H-rho-g, which is H into rho is, since they're using water, 1000 into G. So this gives you 2000 Pascal, right? So the answer should be B. Now the next one, the diagram shows a manometer containing mercury that is sealed at one end. Okay, so this side it's vacuum, so there is no pressure on that side. What happens to the distance h when the manometer is taken higher up a mountain? So now there is atmospheric pressure of say 100,000 Pascal. Now if you go higher up a mountain, the pressure decreases, right? So if the pressure decreases, say it becomes instead of 100,000 Pascal, it becomes 98,000 Pascal, for example. Okay, so if the pressure decreases, what happens to this height? Of course the height, it decreases because atmospheric pressure decreases with height. It should be A, right? Because if less pressure is exerted, this liquid also will be a bit lower because it also has to exert less amount of pressure. This will go down. All right, so the height difference will be lesser, and the height difference will be less because the atmospheric pressure decreases. The next one is the pressure of the gas supply in the laboratory is measured using a manometer. Which distance gives the pressure of the gas above atmospheric pressure? So which distance is giving the pressure above atmospheric pressure? Think of it for a few seconds. Read the question again and think of the answer. Which one should be above atmospheric pressure here? So the answer A is the atmospheric pressure. We don't take the height B. The height C is also not taken. The pressure above atmospheric pressure is given using this much height. Okay, which distance is taken? D. Distance D is taken to measure the pressure above atmospheric pressure. Okay, so these are the things you have to keep in mind. And similarly, the question could have asked you the other way around, that if the atmospheric pressure was greater, say the atmospheric pressure is larger than the gas supply pressure. The gas supply pressure, and this side we have atmospheric pressure, right? So if atmospheric pressure was greater than gas supply pressure, the question could have asked you how much is the pressure below atmospheric pressure by the gas supply, right? So in this situation, the pressure due to gas supply is atmospheric pressure minus h rho g, remember? So this is h, so this becomes the equation. So how much is it less than the atmospheric pressure? This much. So again, the answer would have been h rho g only. Whatever the value of h would have been, you would have given the answer this one. So this one, the question would have asked you how much is the pressure due to the gas supply below atmospheric pressure. And in this kind of scenario where the gas pressure is larger than atmospheric pressure, it would have it will always say how much is the pressure above atmospheric pressure. Okay, so I hope the concept of centimeter mercury is clear to everyone. How do we use it in different questions, and what does it mean to be above atmospheric pressure or less than atmospheric pressure? Okay, all right everyone, so hopefully the problems are solved. Thank you.